Through Executive High School Internship, I had the opportunity to do an internship in a research lab at Colorado School of Mines. And through this internship, I spent over 100 hours in Dr. Kevin Cash's chemical research lab, experimenting with nanosensors made from chemical components. Dr. Cash assigned me an individual research project in which I investigated how to vary nanosensor size. Having a good way to vary nanosensor size could be helpful because larger sensors have the potential to stay in place better in the body when injected, and smaller nanosensors have the potential to fit inside of smaller areas of the body, such as cells. I started my project by working with different PVC molecular weights in my nanoparticles. So I worked with 43 grams per mole, 80 grams per mole, and 90 grams per mole, creating several optodes and nanosensors using each different PVC weight. And after collecting data from the dynamic light scattering machine and compiling all the data into a graph, I realized that there is not a very helpful trend between PVC molecular weight and nanoparticle size. And so from there, I worked a little bit with combining PVC molecular weights to see if that had any kind of different effect than any different individual PVC molecular weight. And unfortunately, this was not successful in fulfilling the purpose of my project either. One of the most exciting parts of my internship was discovering a way to vary sensor size completely by accident. And this was especially exciting because a lot of great discoveries are made by accident, like penicillin. And so one day in the lab, we were out of the plasticizer that we usually use in sodium nanosensors, BEHS. And so I was forced to use NPOE. And after sizing these nanoparticles, I had discovered nanosensors created with NPOE are larger than those created with a lot of other plasticizers that I experimented with. We started to look into using other plasticizers like BEHP, BEHA, or DA. And after working with all of these plasticizers, I concluded that NPOE does create the largest sensors. During my research, I used the DLS machine quite often. DLS stands for dynamic light scattering. And so after I prepare a batch of nanosensors, I'll put it in a little cuvette and take it up to the DLS machine that bounces light off of particles, basically. And there's a lot of other stuff that goes into it, but it provides me with a reading of effective diameter and polydispersity. One of the most promising applications of our nanosensors is constant glucose level monitoring for diabetics. This will eliminate the need for pricking your finger to measure glucose levels through blood. And this is one of the most promising applications because it's one of the most commonly understood. I worked a lot with Excel, putting my data in tables and organizing data in that way. And then from there, I would make my data a little more understandable by using Prism graphing software to create graphs so that I could convey my data. And I've kept a professional lab notebook throughout this whole internship, each day recording what I do in the lab, how my experiments go, if I notice anything weird, and then any data that I record goes in there. So basically, someone should be able to pick up my lab book and know exactly what I did that day and exactly what I concluded from my experiments. Keeping this lab book has helped me in AP chemistry class. I additionally improved my time and task management skills through the execution of my experiments. Through this internship, I've grown as a professional because I've learned how to conduct myself in a real-world lab environment. I've definitely strengthened my communication skills through working with other lab members or Dr. Cash in conveying my research and my conclusions through presentations, graphs, or my lab notebook. And we communicate that way a lot in the lab. So I've really strengthened my communication skills in this way. I've improved my data analysis skills through this internship because I effectively analyze data collected and apply it to my research in order to find a way to vary nanosensor size. This experience has influenced my future goals because although I initially intended to pursue a career in biomedical engineering, I've realized through this internship my passion for chemistry and that I would love to participate in research in college. I appreciate all that Dr. Cash has done to accommodate my needs as an intern, whether it was reviewing my resume or helping me out with my LinkedIn account, helping me figure out how to approach my project or how to solve certain problems during research. All of the lab members have been very welcoming, and the grad students who have helped me out in the lab every day in teaching me how to perform nanosensor and optode synthesis, how they work chemically, how to use Prism graphing software or the DLS machine. Thank you so much for everything that you've done to encourage me as an intern and help me figure out my future career goals.